subtracting fractions, which we're just working with halves so far, think about that in terms of what does it mean to add or subtract fractions where the denominator is not the same. So we used a problem like this. Now I think I know what's going on. It's because I'm pressing a button on this pen. So a problem like that, like 3/2 plus 3/4. So basically we just have to again ask ourselves, what is the whole? And I'm going to call it a circle in this case. And I'm going to say that when I have half of a circle, I have this because that's a half. And when I have a quarter of a circle, I have that. And if you just go back to this whole, you can imagine this, okay? When I split it down in half, you see there's my half. But when I split one of those halves again, I'm going to end up with a fourth. Because if I imagine that if this was cut all the way across, I would have 1, 2, 3, 4, right? So I have my half. I know what that looks like. I know what a fourth of my whole looks like. So now I have to think about adding these pieces together to figure out what does it mean to have 3/2 and 3/4. So 3/2 would be 1, 2, 3/2, okay? And then 3/4 would be 1, 2, 3, right? So now I have to think about what does this mean when I'm adding all this stuff up together. First of all, I'm going to figure out my wholes. I know I can join these two to make a whole, so there's one whole. I know I can join these two together to make a half. And then if I join this half right here with this half, I'm going to end up with another whole. Okay? And what I have left over is this 1/4. So in a different color, I'm going to circle the numbers that I ended up with. I ended up with a whole, right? I ended up with another whole when I added this half with these halves. And now what was left over was a fourth. So if I add up these numbers that are circled in blue, I'm going to end up with 2 and 1/4. Okay? Or if you want to think about it in terms of a mixed fraction, I would have 9/4. If you were to do this algebraically, you have 4 times 2 is 8, plus 1 is 9, and then 9 goes up there, the denominator stays the same. I have 9/4. So if we go back and look at this problem and solve it algebraically, you have to make it so that you have the same denominator before you can add across the top. So in order to do that, I'm going to have to multiply this times 2 and this times 2 in a different color. I'll show what I end up with. I end up with 4 here and 6 here. Now I have the same denominator, 4 and 4, right? So now I can go ahead and add across the top, just as we're taught algebraically. You end up with 9/4. And then when you simplify this to figure out how many wholes you have, you would end up with 2 and 1/4. Okay? So it works. I'll show that algebraically it's the same thing we're doing pictorially. Alright, so let's start this thing new again. We talked about, by the way, we talked about this last problem, this problem right here, with Eric's problem, only Eric was very creative, very unique in the way he thinks about it, and I'm not sure it was clear to everybody in class exactly how he was joining his wholes and his halves and his quarters, but he was indeed doing this. He was just overlaying the halves, or I think it was the quarters on top of the halves. And well, and we did take a picture of his image so we can review that later and come back to it when we have a better understanding of this problem in our own terms. Anyway, but that's just what I just did for you, was a review of how I'd like for you to think about it. Wait, I want to do a new screen here. For the future problems that we're about to do right now. Okay, so again, I think this black screen is kind of cool, so we're going to do that again. And then we're going to pick a new color, let's do green. Alright, so that's how we're thinking about adding and subtracting fractions. But to think about multiplying fractions, what I had you do was just do a simple problem like, let's say, what do I do? I need to make this a zoom in so you can see it. better? There we go. Okay. Ignore my phone. I'm sure it's somebody calling me from class or one of my students' parents. Okay, so if we had, let's just say 3 times 2, we know that's 6. By now you should just know that by memory, by heart. But if we were to show this in terms of groups of wholes, and let's just keep the circle as our whole for now, just because it's just easier to stay with that same thought, then I would have 3 groups of 2. So here's one group of 2 wholes, 2 groups of 2 wholes, and then 3 groups of 2 wholes. And if you add up all these wholes, you have 1, 2, 3, 4, 5, 6. Okay. We also know that in multiplication, you can switch these two numbers around and you still get the same answer. So in other words, if you wanted to do, if you wanted to do 2 times 3, then you would have 2 groups of 3, which would get you this. Here's one group of 3, and here's 2 groups of 3. And again, I have 6. It's just that they're orientated differently. This is what you would call a landscape orientation. This is what you would call a portrait orientation. But they're still the same number of holes, okay, of whole circles. So what I want you to do is think about this same idea of grouping, which we're already very familiar with multiplication with whole numbers, but now do that with multiplication of fractions. And let's take, for example, 3 times 1/2. What does that mean? If we're talking about groups of numbers, then what we would have is 3 1/2. So if I'm going to do this in circles, because this is my whole I'm talking about, all right, then I'm going to have a half circle, which is going to be like that. My dog is now rolling around on the floor. You might hear him. So if you have 3 1/2, you would have 1 1/2. Come on, pen. 2 1/2, and then 3 1/2. If you simplify these, well, first of all, if we say these are 3 1/2, we could write it like this, 3 halves, which, by the way, is the same thing as 3 1/2, which is what we have up here, right? 3 groups of halves. But then when I want to simplify it pictorially, come on, pen, I can join my halves together. I get one whole circle there, and I have 1/2 left over here, which gets me the answer of 1 1/2. Boy, everybody's calling me right now, right when I'm doing a video. So I have 1 1/2, and if you see this 3 halves here, if you were to simplify that algebraically, you again would get 1 1/2. Okay, so that's kind of an easier way to multiply fractions, because we're only dealing with, well, we have one whole number, which is 3, times a fraction. Now let's see if we can do this where we have a fraction times a fraction. So let's clear the screen. New. We don't want to save that. We want our background to be black because it's easier to see. And then I think we'll do, I don't know, can we do yellow for the writing this time? Let's see. Alright, so what if we did one, I'm going to do that because I need to zoom this in so you can see it better.